probability next is the continuous random variables. So continuous random variable is, so far we have looked at the discrete random variable, which can take any number 1 2 3, but not in between. So there is no indefinite amount of possibilities for the number. For example, you have a train coming to a station and it can come at 5:30 a.m. anytime between 5:30 a.m. and 6 a.m. So you have a 30-hour window in which the train can come, and most likely it will come at 5:30, but then it becomes less, but it never becomes zero, but it becomes less and less over the. So this goes on through infinity. So we have to devise some other method to deal with this, because we cannot just have a list like in discrete random variables. We were doing a list 1 2 3 4, and the possibility of it coming at 5:30 is this, and 5:31 is this, but it can come in between 5:30 and 5:31 also. So for example, if I want to choose the time it will come between this, then we write it probability of x less than or equal to 540, or more than or equal to 540, and less than or equal to 545. This means that the probability of the train coming between 540 and 545. So this is the probability distribution for continuous variable. For discrete variable we call it probability mass function, but here we call it a probability density function, or PDF. So PDF is used for the um, for continuous variables. And 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 how do you calculate this? And we calculated this by calculating the area under the curve. So what we basically want to know is the area in this little area. The area of this is the probability density function for this. So, and obviously for calculating area we're gonna have to use some calculus. So this will be an integral from 540, the limits is 540 to 545, and we're gonna say fx dx. That will give you the probability density function of the continuous random variable. So then there are a couple of types of this distribution. Uh, One of the common distribution is the uniform distribution over an interval. Uniform distribution is there is no preference. We have, for example, we have say temperature is between 30 and 32, and there is no difference in the uh, probability of it between 30 and 32. So the fx is the same for those for the different variables. There's no spatial preference for that, and that so that probability function of this needs to be flat. But how should we assign the height of this function? This is a law of total probability we have seen before, which says that the total probability needs to be, so the area of this whole thing needs to be 1. So if the area needs to be 1, we know that area is going to be length by height for any rectangle. So 1 is equal to length by height. So height becomes 1 by length, and it is already 1, so that is height becomes 1 by length. So but if it's a square, this will be 1 is going to be 2 times the height, so then the height becomes 1 by 2. So f of x in a square uniform distribution is going to be 1 by 2, where x is more than 30 and less than 32 and 0 otherwise, and you will write it as 30 32 fx dx. So really it is minus infinity to plus infinity fx dx will be equal to 30 32 fx dx, and that is going to be 1, because the probability of minus infinity to 30 and 32 to plus infinity is 0. Now if the question is what is the probability of temperature between 30 and 31, so this is the question, and you need to do the integration of this. So this is 30 and 31 fx dx. Since the fx is half, you can calculate it using integration just by putting fx as half in it. So you will just write it as 30 31 half dx will give you the probability of it.